Good morning, students. In previous presentation, we discussed about what are the tools and techniques for smart grid. So, how it is used for improvement of effective utilization of power. Power. So that is what is our output is. We have to maximize the profit and minimize the loss. So, in continuation, we are going to discuss nonlinear programming. So, what is nonlinear programming? What are the challenges for nonlinear programming? We discussed here. So what is nonlinear program means when the constant functions which are using the function they are nonlinear, then the constrained optimizing problem is called as nonlinear programming problem. So in this we use a global minimizer as vector x dash such that minimize the f of x subjected to x belongs to s. So finding global minimizer is normally the goal of any minimization problem. But sometimes local minimizer also we have to consider. So in this the conditions to be satisfied f of x dash equal must be belongs to f of x, and nonlinear programming in many instances specified by functions that are differentiable or even continuously differentiable over the feasible regions. So nonlinear programming typically employs Lagrangian or Newton's techniques for constrained and unconstrained optimization problems. So the approach assumes that objective of a functions are modeled and smooth and continuous functions. However, mathematical response of power system diverges from assumption in many instances. So the theory distinguishes in two cases, develops first order optimization and second order optimization. So coming to the general structure, so we have to maximize the f of y and subjected to ci that belongs to f function of y and that belongs to di. So the procedure to use it to solving nonlinear programming class, the procedure to be taken, determine the initial feasible set, check the optimal conditions, determine the candidate solution for local and global optimum, perform further optimization and evaluate the optimal value to objective function that satisfy the constraints. This is the general procedure for nonlinear programming. Coming to challenges, large computational burden, limitation to static variables in the objective and constraints suffers if the approximation to the actual mode. Therefore, research is needed to increase the smart grid feature if they are to be used as computational tools. It requires adaptive, predictive, and stochastic algorithms for improvement of nonlinear program to overcome the challenges of nonlinear programming. So there is a large computational problem is the main burden in nonlinear. In this, we have to optimize the solution for nonlinear constraints. So united approach to optimal real and reactive power dispatch. I will share the necessary paper for this. You refer this paper. If you have any doubts, ask me. I already explained in the class what is this paper deals with. So it is an example for a united approach to optimal real and reactive dispatcher. So this is about all non-linear program. How non-linear program is to be used as a tool and technology of smart grid. And next we are going to discuss integer programming. So it is a special case of linear programming where all or some of the decision variables are restricted to discrete integer values. For example, where the discrete value is restricted 0 and only that is yes or no decisions are binary decision variables. So first we need to maximize the function p of x that belongs to ci and xi subject to some constraints. So this problem is called linear integer programming problem. It is said to be a mixed integer program when some but not all variables are restricted to be integer. It's called pure integer program. So the branch and bound procedure features we are going to use in this. First we have to initialize a set px to infinity. Px is the optimal value of p function. So next we have to do branching, that is involves two variables, one is 0 and one is off, and bounding. For each subproblem a bound can be obtained to determine the goodness of Best feasible solution. So optimal test is required. The iterative procedure stops when some problems remain at this stage. The correct incubate of P is got optimal solution. So until when we the output become optimal, we have to do the procedure. So this is the example. Determine z maximum of z value function 5x1 plus mx2 subject to x1 plus x2 belongs to x, 5x1 9x2 belongs to 45, x1 comma x2 greater than and integer 0. So for the problem solution, I will share in the YouTube link. You refer that and practice and come with the solution. So this is what how integer program will use it to get the optimization. Next, heuristic optimization. It is a computational procedure that determines optimal solution by iteratively trying to improve candidate solution regard to given measure quality. So heuristic implements some from statistic search optimization, such as in this we are use evaluation programming and genetic algorithms, genetic programming and differential evaluation. So future work accounts for the predictive and statistic nature of smart grid involves modeling of components to account predictive and statistically selecting new optimization techniques in order to obtain the feasible optimal solution. So new optimization strategies are proposed as model a new objective function, model RER to account staticity and variability, update model and simulate, define new system components. Following the solved probabilistic load flow for base case studies. For this, you use Newton techniques. Select appropriate optimization technique, which may include heuristic program technique, and upgrade for ADP methods that define the impact of predictivity and statistic of optimal. So this is the optimization strategy proposed based on these techniques. Okay, thank you.